Doing well. Today class will be very like super class. Okay, be careful because just wait. Okay, then you will let you know better. Okay, why I said like that. So first, first problem, my dear students, from song strength of material. Okay, first I will cover some problems of song. Then fluid mechanics. Then civil students can leave the class. Okay, like that. Then mechanical, like we will do on through machine and these vibrations. Okay, so first problem, this is from SOM. Okay, so what is given in this? What happens to this? 1 minute, dear students. Okay, so this is pen. So see this problem very important. This is a road, okay, and this is fixed. This end circular cross section uniform throughout, and this is a spring. Okay, this is a spring, and this side is also fixed. Okay, so very important. Now what first you are like have done problems like when temperature was constant, okay, throughout the temperature change, okay, or temperature gradient was uniform throughout the length of the road or bar, something like that. But now see in this problem temperature is of varying nature. Okay, so here it is like it is given temperature profile T is 25 into 1 minus x square by L square, something parabolic. Okay, very important. So now next, so you have to find out stress developed. Okay, I written there what you need to find out. Stress developed in the bar in megapascal. So let's begin this problem. So what is happening there? See now, this is fixed both side. Okay, this system. Okay, composed of rod and spring. So this when temperature will rise. Let us suppose the temperature will rise. So compressive stress will be induced. You know better. Okay, in the rod, and then but due to fixing on both sides, so bar cannot elongate like this side. Okay, it will get resistance. So what is that? So first let me show you. Suppose this is a bar, okay, like that. So first let it is free, okay, in free state, not fixed. So what will happen due to temperature change in the bar? This side it will extend, and this side, okay, so there will be change in the length of the bar and it will elongate. Now what is happening due to this fixation? So this whatever change, this, let us suppose delta, whatever due to temperature, okay, delta, so this will be registered. So due to fixation p, so when you due to this fixation, so this will be remain in the state of this. So this will be positive nature due to temperature change, due to temperature, okay, gradient, due to temperature gradient delta t what you take. And now what is happen due to this fixation p, let us suppose that is you apply p or like fixation. So fixation will apply P, then resistance this P, and due to this, then this delta will be same magnitude but will be in negative directions due to this. So bar will be exactly this position like that. Be careful. So this is due to this resistance. Okay, due to fixation, very important. So now let us start and do this now. What is happening now? First you have done problem like okay, like this now. So temperature is given, so how will you do? You have to take a strip, very important now, my dear students. You have to take a strip in this. Okay, be careful. So what you will do, like d delta t, let us change in temperature gradient alpha, length of the alpha into tx into dx, very important now, my dear students. So take a strip now over there like this, and let length of this is dx much, dx much, very important, dx. And let us suppose you are taking at a distance from this side, okay, from the this end, free end, like this side, okay, this end. And this is given also like that, okay, from this side. So here I have shown to you like this, from It is actually from there. Okay, I don't know why, but I cited like that in PPT. So from this, so this you need to remember at any cost. Be careful in this, very important mind. Here you can take T also, not a problem, because temperature, outside temperature will be constant here, like it is for T infinity there and like that. So delta T when you get there, and this is temperature, so T minus T infinity over there like that. So that is constant at T infinity outside. So you can write D delta T, or you can write also T. That's not a problem here. D of T is equal to L alpha dx. This is important now. So length of the strip differential. So now you need to integrate, just nothing is there. So you need to find out there now, due to temperature change. So this is delta and this is d, not T. This is delta. Delta, my dear students. Delta. This is delta. Sorry for that. This is delta. Okay, change in the total change. So now you need to integrate it to find out the total. Okay, very important. There you can take it is better differentiation, and delta you have taken. That's okay. That's okay. So now integrate it alpha tx dx from length is given 0 to L. So 0 to L, x limit from 0 to L. So now next step, you know what you need to do. Okay, so alpha is constant throughout of the road, and tx, now put this there, 25 multiplied 1 minus x square by L square into this, okay, bracket, and then dx. That's okay. So now we need to find, so you will get delta total, my dear students. Once you integrate it, so this is easy, like integration is easy, not a big issue for you. So delta you can find out here. So delta, once you get delta, now next step, because you need to find out stress at any cost. So next, so what will happen now? Very important part. See, some basics you have done. 1 minute. Let me do it on next slide. So now see, temperature is like, how do you get delta total? If they ask you total elongation of the bar, so you will do like that. Now come to next. So see this very important part now. So in this now, you done one basic problem, like there are two bar connected in series and fixed on both sides like that, and let us suppose it is alpha 1, this is having alpha 2 like that. Okay, so what you done, like alpha and temperature change is same through like that in both the systems. Temperature changes delta T like that. That is uniform case something, but I will take you there. Okay, Alan, because you will get also this in detail. So due to temperature change, so in this bar I am taking net. Okay, so first I am taking of this bar 1, so delta due to thermal effect. Okay, delta T1 due to thermal effect. So alpha 1 into length of this, let us suppose L1 into delta T, then delta T2 due to thermal effect of this bar, and because this will be positive nature, be careful, because and they will due to temperature when they are in free state, so they are going to extend, elongate. So delta T2, and that is also plus nature, be careful. And then now due to resistance, now this bar cannot elongate. See this, whatever when they extend, so due to resistance, so whatever this is not possible. Okay, so that is resisted due to P much. So this side, let us suppose P is coming in, these are in series, so there you will also get P, like this bar, one bar in this P is acting, so over there you have to, you know, the, that is basic, I am not teaching that. Okay, you know, this side P, like bar will be in what state? Compression. So this will be in compression, and this will also be in compression. Be careful, bar number 1 and 2. So due to this, now what will happen? There will be like delta due to this P in bar 1 will be equal to what, you know, P1. This is some basic P1 L1 length, P1 L1 by A1, area of this bar, take what is cross sectional area by A1, this, and likewise get for this delta P2, P2 L2 by A2 E2, you will get this due to P now. So now very important, if they ask in this system, like, so you know this basic. So now what happen in here, if they ask you net of this bar due to this net, so delta net of 1 will be, my dear, this is positive, be careful, this is positive, and this will be negative. So this will be negative P1 L1 by A1 even. This is negative, be careful. And then delta net 2, if they ask you, alpha 2 L2 delta T. Now this is also negative compressive nature, P2 L2 by A2 A2. This is A1, be careful, A2 A2. So then if P1 P2 is equal to P, you can put there PP like that. And then delta of the system, delta of the system will be 0, very important. So delta net 1 plus delta net 2, this. So this total will be 0, my dear students, be careful. So then put these values over there, like this value, this delta net there, and this put there, and to get P, so you can get P. And then if they ask you stress, like then P by A1 and sigma in 1 and sigma in 2, P by A2, P1 by like that, these are same, so you can get stress value. Okay, and then see what is positive or compressive like that here, because you cannot say this bar alpha 1 and alpha 2, it will depend. Alpha 1 is more than alpha 2, alpha 2 is more than alpha 1, then you will get like net compressive or tensile distress. Okay, be careful, you have to do this, you have to find out like that. Then if it comes positive, then tensile. If it comes negative, then this is compressive nature. So like that. Now come to what happens now in this problem. Bar is one, there is one bar. Now they have replaced this bar with a spring now. There, what they have in this problem? Spring. Now very important part. So what will happen? Same concept used there. So this will be same idea. This delta net 1 will be same for this bar. This, okay, be careful. Then plus, very important now, spring. So it will depend now spring. Okay, so spring, now see when this bar will change due to temperature, because this end is free, this end is fixed to this side. So due to this, spring will be in compression state. So for compression state, you will take negative. Okay, be careful. And what is deflection in spring? Stiffness into deflection in spring, delta S in spring will be equal to load. And what is load? This side or whatever this side P, that is B. So K into delta, so very important. So now put there this delta S of spring compression, whatever will be net of this bar, like this, will be equal to this, very important, will be equal to this delta S. Delta S is equal to, net will be 0, net will be 0, because the system, this is entire system, net will be 0. So what put their value then, there, this put there delta S, put delta S here, put P by K. Okay, put there this and get P there. And what value they are asking? Stress value, that is load by area or bar. So you can get like that, so be careful. So this was the problem. Okay, this was the problem, but very important now here, you have to replace this part. Okay, be careful due to temperature. Okay, and don't, you can't put this is uniform. Okay, whatever this part, like this part. Okay, be careful, concept is same, but here you have to replace this what you got in last. Okay, due to known temperature uniform distribution over the length of the road. Okay, so here you have to replace this only, this, whatever value you get, this as it is, this you have to take as it is, this replace with the last value minus then this. And now very important, this part, resistance, how resistance you need to see, like this side spring cannot move like that, this, so spring will be in compression state, so this will be like that. And when you take force on spring in this side P, so automatically then this side you have to take superposition principle, so P, and this side is P in bar road, so this is compression state. Be careful, compression state. So this value negative, you have to take this part, and this due to temperature positive, you have to take. So put and get p value. So this is the first problem. Now come to next problem. Okay, you will get much and much. Okay, be careful. There can give you 3 bar like that. Concept is same throughout. Be careful. Delta of the system net total 0. Find out net 1, net 2. Like that, put their temperature, and due to then see superposition, what you principle you apply, reactions, compression or react, like due to P, there will be like in compression or tension like that. That superposition basics. Now come to next problem. So this was the first problem. Very important. Am I audible to all of you?
Yes, sir.
Yeah. Okay, so be
Yes, sir.
careful. Problem
Sir,
will be very.
that slide,
Yes. See this. Very
sir,
important
that
part.
P1, P2 is extra force you have put from outside. Or...
which P2 not extra. This is due to fixation because first bar, suppose bar are in free state due to temperature, so they are not going to be registered. Stress will be zero due to temperature change. So what will happen? Only temperature, free state. But fixation are there, so fixation will exist na. So whatever they try to extend due to temperature, that is not possible. That much is resisted by this fixation, and fixation will providing this side P, and these are in series. This side also P. So series loading is same. Be careful. In series, P will be same throughout the bar. If they are in parallel, then P will be total. P1 plus P2 like that. That will be distributed. Here these are in parallel, so P will be throughout the same spring. How 3 bar or 4 bar in series like that. Be careful. Got it?
Mm-hmm. Yes, sir.
Be careful. So now next problem, very important problem, my dear. This is a torsion problem. Okay, tapered bar. Okay. So first let me take pen. Okay. So this is what is given. Very important. Okay. First, very basic formula that you need to remember. Then problem first, something I am letting you know. This is very important. Okay. So let us suppose this is the diameter is d2. I am taking just a d1. Okay. Let me take d1 and d2. See now this is more. So 2 is more than 1. To remember formula, I am telling you my formula when you remember. So what I am saying, this length is more, diameter is more. Okay. So d2 I have taken. 2 is more than 1. To remember my formula. Now come to what will, if they ask you volume, what is volume of this frustum of a cone? This is a frustum of a cone actually. Frustum of a cone. Frustum of a cone. What is the volume? So this side volume very important of this. So pi by 12. I am not like if you want to find out it, like you can find out. I am telling you if you forget. So take dx much at a distance x from this end, and then volume you need to find out. Small volume first, area. So that is area is there, and diameter will be there something. So diameter will be there. So let us go dx. Okay, at a distance x. So volume will be equal to pi by 4 dx square area at this and this length, because this is a differential element very small. So dx. Then you need to integrate it to get a total volume of this first term of a cone 0 to L. So length is L of the frustum of a cone. So dx, how will you get dx? Remember dx now. So d1, if you take d1 side, d1. So d1, what you will get? D1 is smaller value, but this dx will be more than d1. So that you have to take their plus. But if you are finding this with respect to d2 dx, so then d2 is more, dx is less. So you have to take their minus. This value will be same in both. What I am writing now, d2 minus d1, more minus less. Okay, divide by L into x. Same thing you have to put here. So but remember one, y2, so this is enough. Okay, this is enough. D1 plus smaller plus, if larger minus, then you know very well. So remember this. So put this formula there, then you have to integrate it. Okay. So pi by 4 dx ke dx, yes. So put this, get it, and then what you will get, what I'm writing now, you will get this pi by 4 d1 square plus d2 square plus d1 d2 into L length. So this is the volume of the first term of a cone. Now very important part here, my dear students, something how to remember. So everybody know pi, this pi L, this will come into picture, but they forget like 12 or what is there. Simple, my dear students, this is 1 2, this is 1 2, 1 2, 1 2. Remember from this, oh it is 1 2, like simple. And special case cylinder, let us put d1 d2 throughout same, dx, these are same throughout. So diameter, so what will you get? Volume. You will get cylinder, my dear, cylinder. So pi by 4 d square, put their values, d square h, pi by 4 d square h L length. So you will get this, put there 3, you will get 3 d square, 3 4 4 is 12. So 4 you will get like this. So this is very important part.